All right, we're going to learn about the law of sines today. This is um, an idea that is used in solving for side lengths or angles in non-right triangles. Okay, so yeah, we couldn't use just regular old SOHCAHTOA here to solve for like angle C here or for this side here. So we have to use something different. So one way to do that is the law of sines. Okay. So here is the formula. I'll go ahead and post a link to the proof of this, but I'm not going to prove this here. But so basically what this says is the sine of one angle in a triangle, like say sine of angle A here, over the side length opposite it, so this would be side length A, is equal to the sine of angle B over its opposite side, and same with angle C and its opposite side. So all those ratios are equal. Now, we really only need to use two pieces of this to solve for something, right? We have sort of this weird looking formula that has two equal signs in it. So, we just choose what we want. We either use this or those two, or even the two on either side here. Okay, so let's see how this works. So here I have a triangle. I'm asked to find all the missing lengths and angles. So one thing I notice is actually the angle will be pretty easy to find because we have two angles already. So in order to find the missing angle, we're just going to use the triangle sum theorem that says all the angles in a triangle add up to 180 degrees. So let's do that. Okay, so we got 103 plus 37. That's 140, and then take that away from 180. We're going to get 40. So that means that angle C is 40 degrees. Okay, so we found that angle just by using some basic geometry here. Now we need to find these two side lengths. So again, looking at this formula here, you'll notice it's always like an angle and its opposite, an angle and its opposite. So we definitely need to have, in order to have enough known information here, whatever version of the formula we use, let's just say we do this for now, you'll need to know three of these pieces of information, any three, in order that you only have one unknown. So I'm going to go ahead and involve side A and angle A because I know both of those. So I'm going to have that part of the formula. So let me write that down. Okay, and then depending on what I want to find out, I'll use that part of the formula. So I'll go ahead and just find B first. We'll go alphabetical order here. So I'll do sine of B over B, and then we just plug in what we know here. So sine of angle A is, or angle A is 103. And then side A is 47. Angle B is 37. Oops, can't see that. There we go. Okay, and then let's see, side B is our unknown. Okay, so now we just need to sign this. Now we need to solve this. So the best way to go about that, since we have a fraction equals a fraction, is to cross multiply. So we're going to do that. So we're going to get B times the sine of 103 degrees equals 47 times the sine of 37 degrees. Okay, and then in order to get B by itself, we have to divide by the sine of 103. You don't want to grab the calculator yet. We want to make sure our answer is nice and accurate, so we don't want to round numbers until the very end. So B is just going to equal this business. So I'm going to go ahead and put that into my calculator now. Just have my phone calculator today. So let's see, we're going to get, so 47 times sine 37, okay, and that equals, I'm going to go ahead on this calculator, just hit equals, and so we get that, and then we want to divide that by sine 103, so divided by sine 103, and we get about 29.029. It didn't say how to round here. I'm going to go ahead and round to the nearest tenth, so that'd be 29.0. All right, so B is approximately equal to 29.0 kilometers, because that was what was involved elsewhere in the problem. All right, I don't have my best equipment with me here where I'm doing my video right now, so I just kind of folded my paper so I could fit everything on the screen. All right, so now we need to find side C. So I'm going to use, again, I'm going to stick with sine of A over A. You could use, we found B, and we know what angle B is, but this is a rounded value, so we want to avoid that if we can. So let's go ahead and use angle A and side A, and then we want to figure out what side C is, so we're going to involve C here. So we're going to actually use, this was sort of the first and the last part of that formula, right? Okay, so now we just plug in what we know here. So sine of A is 103. Okay, and then angle A was 103, and then side A is 47. Angle C is 40. And then we don't know side C, so we're going to find that. So C times sine 103, and then that equals 47 times sine 40 degrees. Then we're going to divide by the sine of 103. And we get C is approximately equal to whatever this is. I'll go ahead and put that in my calculator here. So, all right. So 47 times sine 40. And then we'll divide that by, now the way I'm doing on this calculator, I guess I am using a rounded value, but it's out to so many decimals, it's not going to matter for the precision we're getting here. And then divided by sine 103. All right, so about 31.0. If you just, wrote 31, that's fine, but some of these might have some decimals other than 0 on them, so I'm just choosing to round these to the nearest tenth. So I'm going to do part of number 2, even though this is a your turn, just because this one we can't find the angle measures just by using basic geometry. So how do you use law of sines to find an angle? So let me do that, and then I'll let you do the rest of it. So first of all, let me label this. Now, you notice this is R, S, and T instead of A, B, and C. The letters really don't matter. From the formula, it just, if you think about what this means, it just means you take the sine of an angle, divide it by the opposite side. Sine of an angle divided by the opposite side. That's all that means, okay? So it really doesn't matter that we have the different letters here. I'm going to go ahead and sort of customize the formula for this triangle here. So let's say I want to find, well, pretty much I'm forced to find this angle. The reason being I see that I have the side opposite it. Angle T would be hard to find. You couldn't find it right off the bat because we don't know what the side is opposite it, and we wouldn't have enough information. So let me find angle R. So that means we're going to have sine R over R, which this side would be R, and this side over here would be S, and this would be T, little t. And then we are given angle S and its opposite side, so we want to involve those. Okay. Those are S's, not 5s here. All right, so now we can plug in what we know. So sine of R, we don't know. R is 26. Sine of S is 58 degrees. And side S is 35. All right, so just like before, let's cross multiply. We're going to get 35 times the sine of R equals 26 times the sine of 58 degrees. And we want to get sine of r by itself. So there we go. It's by itself, basically. And, oh, it is by itself. I just don't want to rewrite it. So we need to, I will write one more step here. Actually, if we think about what we have to do at this point, well, I'm not interested in just what the sine of r is. I want to know what r is. So in order to undo the sine here, what you do is you take the inverse. So you use inverse sine. So we're going to be actually doing this on our calculator. Now there's different ways you could put that in depending on your calculator. I'm using a phone today, so which is a little clunkier than some other calculators. So what? Okay, well, I started to do that on my phone calculator, and I realized it doesn't do inverse sine, so I had to go download another app. This is actually the Desmos scientific calculator app. I see that they have one just for scientific calculators, so this is a pretty good one. Okay, so back to this. Yeah, I think since I'm using a better calculator now, I'm going to go ahead and put in the whole thing. So let me go to inverse sine, and then I want to go 26 sine 58, and then need to close up those parentheses here. There we go. And then divided by 35. All right, yeah, this is nice. Look how it formats it there. Okay, so so we have 39 degrees is what this comes out to. If we take the inverse sine of all this business, we get about 39.0 degrees. So let me go ahead and write that down. All right, so that's what r equals. So I'll let you do the rest. What you need to do on these your turn problems is find all of the missing sides and angles. So let's go ahead and do that. Number 1 here. The missing pieces, of course, were y, which I guess I didn't circle that. So y equals 41 degrees, right? We did that just by basic basic geometry. And then in order to find side x here, I did sine of y over y, because I then had the angle measure and the side opposite, so I want to involve that. And then, of course, I wanted to involve x because that's what I was looking for. And so I used this setup, plugged in what I knew, solved for x, and then I just needed side z. I went ahead and stuck with angle y and side y since I knew those exactly. And then